Hi, my name is Siripu, and I am a junior student in Environmental Systems Engineering in Penn State University. I just finished my study in EM 303, so I want to combine some basic fluid mechanics principles with what I'm interested in. Today, my presentation topic is hydropower generation and turbine. So first, I will introduce what hydropower is, and then I will analyze the energy transformation in hydropower plant with using some fluid mechanics principles. And finally, I will talk about some types of turbine and their features. Hydropower. Hydropower, when you first heard of the term, it is obvious it is about the energy in moving water. And it is also the process people using the energy in moving water to transform in other forms they may use more efficiently, like electricity. It is very important for now, like it is the largest source of renewable energy on the earth. It is also very important back in history. It is the first method people ever used to generate electricity. About 6.6% of US electricity generation comes from hydropower in 2019. And on the right, there is a chart shows the hydropower generation and the share of the total US electricity. So as we can see, it is very important. And so there are also different types of hydropower generation plants. For today's presentation, I will mainly talk about these three types. The first one is impoundment. And I guess impoundment is the first type of hydropower plant when people first heard about the term hydropower plant. It includes a dam and to hold the water back. So the high reservoir and the lower reservoir have a difference in latitude. So people can transform the potential energy into kinetic energy and then the electricity energy. Yeah, so another type is a diversion. Diversion is to use the kinetic energy in flowing water and to generate electricity. The third one is pumped storage. This type is like a big battery. When the energy demand is low, like when late in night, people do not need electricity to work. Um, the excess electricity generated from the system will be used to pump water back to save energy. There are some elements in hydropower plants. First one is dam. It is included in it is included in most of the hydropower plants, but not in the divergent type. And spillway is a way to is a pipe to uh, let the water leave the high reservoir in to prevent the overflow of the high reservoir, also the dam failure. And the penstock is a pipe connecting the turbine and the water flow. A surge tank is a tank on the pipe. This tank can hold water and control the water pressure to make the turbine work most efficiently. And another one is turbine. Turbine is a core part of this energy generation plant. It can transform the potential energy or kinetic energy in the moving water into what we will use the electricity. So the pump may be included in the pump and storage system. Now I'm going to analyze the power generation plant with this equation, and I believe most of us are very similar if we took EM in 303, the Bernoulli equation. For impoundment, we want to use the potential energy of water from the high reservoir and transform it into mechanical energy of the and of the turbine. So as the high reservoir and the lower reservoir all stay in atmospheric, so the atmospheric pressure are same, so we can take out these two terms. Then we assume this is a big tank, so no kinetic energy difference. We can take these two terms also, and no pump, so we can take out the pump head. Then we reach this final equation. The turbine head is equal to the difference between the latitude and minus the head of loss. So another type of hydraulic power generation is diversion. This type of power generation, we mainly want to convert the kinetic energy from moving water into mechanical energy in turbine. So let's assume that the difference in latitude is very small that we can ignore it. So we do not care about the potential term, or so not yeah. So we can talk about the pressure term and latitude term, and there's no pump. So we reach the final equation that the head of turbine is equal to the difference in the head of velocity minus the head of loss. Also, because of kinetic energy is equal to 1/2 times m times velocity, the maximum power output can be calculated with this equation. This final type is pump and storage. It is similar to the impoundment type. However, there is a pump head in this equation. When the energy demand is low, the electricity generated from the power plant can be transformed into mechanical energy again. So, as we derive in this Bernoulli equation, we have found out that the head of turbine in this condition can be concluded that it is a difference in head of latitude minus the head of loss and plus the head of pump. Yeah, we mainly talk about different types of power plants, and as we can see, the power plants have different types of need. Like in the impoundment, we convert the potential energy into mechanical energy, so we need a large difference in the latitude between the two reservoirs. However, in the flowing water, we convert kinetic energy. So what we need is a high flowing rate. Um, to to suit this different need of types of hydropower generation, different types of turbine are needed. Um, for now, I'm going to talk about three types of turbine in this presentation. The first one is Pelton turbine. It is suitable for high latitude and low flow rate. The second one is Francis turbine. It is suitable for intermediate latitude and intermediate flow rate. The third one is a Kaplan turbine. It is suitable for low latitude but high flow rate. Yeah, so the first one is Pelton turbine. It is a kind of impulse turbine. Impulse turbine require a tangential flow of water on the side of the turbine runner. So it can be seen from this diagram in the um, right side. It can only operate under partially submerged conditions. Also, with high pressure heads, it will make the turbine turn very fast and thus generate power more efficiently. So it is suitable for high pressure head and low flow rate conditions. Francis turbine. Francis turbine is a kind of reaction turbine. The flow of water enters this turbine with radial direction and exits in this direction. The reaction turbines are suitable to operate when they are fully submerged and hold in a container so the water pressure can be controlled. It is also suitable for lower latitude heads and lower pressure heads in other words. It is also the most common turbine used in hydropower plants. Kaplan turbine. It is another type of reaction turbine and it is suitable for low altitude and high flow rate, which is in the running waters or the divergent type of hydropower plant. And yeah, so to conclude, there are different types of hydropower plants suitable for different conditions for people's needs. Also, to fulfill the need of different types of hydropower plants, we need different types of turbines. In the analyzation of this kind of needs and different types of tools we need to use, the terms of fluid mechanics are very useful. Since the hydropower is so important today, the fluid mechanics principles of them should also be known. Thank you.